హాయ్ ఫ్రెండ్స్, నేను శ్రీనివాస్. మీరు చూస్తున్నారు కేబీ టెలివిజన్. వెల్కమ్ టు ఈ క్లాసెస్. ప్రపంచవ్యాప్తంగా నిత్యం చోటు చేసుకుంటున్న ఎన్నో ఆవిష్కరణలకు రసాయన శాస్త్రం మూలమవుతోంది. అందుకే ఈ సబ్జెక్ట్లో నిష్ణాతులయ్యేందుకు చాలామంది విద్యార్థులు ఉవ్విళ్లూరుతున్నారు. సరిగ్గా వీరి కోసమే కేఏబీ టెలివిజన్ కెమిస్ట్రీ క్లాసులపై ప్రత్యేక శ్రద్ధ పెట్టింది. అనుభవజ్ఞులతో క్లాస్ నిర్వహిస్తోంది. మరి ఈనాటి కెమిస్ట్రీ క్లాసులోకి ఎంటర్ అయిపోదామా? నిన్నటి ఎపిసోడ్లో వాల్యూమెట్రిక్ అనాలిసిస్ టాపిక్ గురించి నేర్చుకున్నాం కదా. మరి ఈనాటి ఎపిసోడ్లో కెమికల్ ఈక్వేషన్స్ గురించి తెలుసుకుందాం. మరి ఈ టాపిక్ను కెమిస్ట్రీ బోధనలో అత్యంత అనుభవం గల త్రివిక్రమ్ గారు వివరిస్తారు. మరి ఆ వివరాలేంటో తెలుసుకుందామా?
Dear students, today we discuss the vital basic concept or the requirement of chemistry, that is about chemical equations. When you hear chemical equations, people generally think that it is a bit boring or it is tedious work and it is not a big conceptual work like. But it is not so. Chemical equations are very interesting and very useful to understand chemistry as well as to have basic strength in chemistry, and particularly to get confidence in chemistry. It is very, very important, particularly how we balance the equations and how get command over the reactions. All these depend on how best you can write and balance the chemical equations. So, today we will first understand what is a chemical equation and then think what to do next. A chemical equation is nothing but a symbolic representation of a chemical reaction that occurs. That's why there is a rule while writing a chemical equation. We should write a chemical equation only when you know that reaction takes place. It is not to predict a chemical reaction just by writing a chemical equation. We should know the reaction first and then symbolically represent that with the compound formulae. This is called chemical equation. So, for example, if we think of a reaction like magnesium wire burnt in oxygen. We know that magnesium wire, when burnt in oxygen, it forms the magnesium ash, that is magnesium oxide. So here we know that magnesium reacts with oxygen and forms magnesium oxide ash. That's why the reaction is a known reaction to us. Then only we should write the equation. The equation should not be written unless you know the reaction. And we know that magnesium, when burnt in oxygen, combining with oxygen and forms magnesium oxide compound. So this is the way we represent the reaction and we show that chemical reaction in this way completed. But here, after knowing that magnesium and oxygen reacting to form the product only, we could write the equation. And we have some conventional representation saying that whatever we put on left hand side, they are the substances interacting. So we call them as reactants. Newly formed one, the product, magnesium oxide formed here. Like this, after knowing the fact about a chemical reaction, the representation, symbolic representation, we call as chemical equation. So that is the rule, to write the chemical equation only if you know the reaction known to us. Then, for any chemical reaction, after representing symbolically that in this way these are reacting and the product is formed, your very important requirement here is to balance a chemical equation, because according to law of conservation of mass, a chemical change cannot make any big difference in the masses of the substances. Therefore, in a chemical reaction, it is must to see that total weight on left hand side and right hand side, the mass of the whole mixture before the reaction and that after the reaction equal to one another. Therefore, in writing a chemical equation, we should definitely be sure that atoms of every element find equal number on both sides. For example, in a simple reaction like this, magnesium and oxygen, two elements are involved. If you see left hand side, you see 2 Mg, 2 magnesium atoms. Here also 2 Mg, 2 magnesium atoms. And here 2O, 2 oxygens. And here it is having 2 oxygen atoms. So oxygen atoms are equal on both sides, and magnesium atoms also equal on both sides. Like that, seeing that everything equal on both sides is called balancing of a chemical equation. There are few more small things you must notice when a chemical reaction is being balanced. For the sake of balancing hurriedly, we should not commit certain mistakes. For example, by balancing an equation, compound should not be different. For the sake of balancing, we should not put different compounds. We should not change the product. We should not change the formula of the compound. So these are all some important basic fundamentals required. For example, element hydrogen, element oxygen, they combine to give water is a chemical reaction. But while representing this chemical reaction, we should follow certain rules. That is, while writing a substance, the raw formula should be correctly represented. For example, hydrogen has a formula like this, oxygen has a molecular formula like this, and water has that formula. So for the sake of balancing, we should not change the formulae, we should not change the compounds. For example, if anybody puts 2 here, it looks like balancing, but we should not say that it is a balancing, because balancing should not alter the substance. It is the reaction we are talking about, element hydrogen, element oxygen combine to form water. So it should represent exactly those only. That's why we call it as symbolic representation of the chemical reaction. So hydrogen element, oxygen element combining to give water. So it should be reflected there. Then balancing. Balancing is only by putting multiples before those substances. Suppose here 1 hydrogen, 1 oxygen, 1 H2O I put. But this is not balanced because oxygen atoms only 1 pound right side, but here 2 pound. So you must adjust that. So for the sake of adjustment of these atoms, fundamental observation is that we should only put some multiples in such a way that atoms on either side become equal. For that, here we can do like this. Now it is found 2 into 2, 4 hydrogen atoms, 2 into 2, 4 hydrogen atoms, 2 oxygens, 2 into 1, 2 oxygen. So just by putting suitable multiples, we should see that atoms are balanced on both sides. This only is called balancing, not to alter the compounds. Okay. Next, in balancing these equations, actually it appears like simple account settlement. See that so many hydrogens here, so many hydrogens there. You must see that everything is balanced on either side. This only, the balancing. But in balancing an equation, depending on the type of reaction, we need certain procedure to follow so that the balancing becomes comfortable. Fundamentally, we can classify the reactions in these 3-4 types: acid-base reactions, precipitation reactions, very simple decomposition processes, or redox reactions. Among these, for these acid-base reactions and precipitation reactions and even simple decomposition reactions, we need not strain too much mentally. We can comfortably balance these equations just by counting the atoms on both sides, just by hit and trial method. For example, say sulfuric acid reacting with potassium hydroxide, forming a salt, potassium sulfate and water. It is an acid-base reaction.